through his opinion on why he thinks life might be unique to Earth. Mine is just a state of affair right now, what's happening in astrobiology. But when it comes to thinking about what is life, the two of us agree that there is an incredible paradox right now in astrobiology, which is that we are searching for something we have no definition for. In fact, we have 120 so definition for life. So I often compare this as a postcard where you have many different features in your postcard. You would have a landscape with hills and skies and clouds, and everybody is looking at their own part of the landscape with his own tools, and each is giving a definition to life. It's different from the neighbors, but doesn't mean that it's false. It just needs that we need to put the pieces together. And I think this is what astrobiology is trying to do. But searching for something we don't know what it is extremely difficult. And the other level of difficulty is because we are both the experiment and the experimentator, which is against the scientific process. You usually don't want to be involved in your experiment, but we are by definition. And this is probably one of the points I like the most in Jean-Pierre's book, is how we separate ourselves from nature. And I said that in different ways by saying that there is no separation between what we call life and non-living. I agree with you, Jean-Pierre, that it has to be a transition somewhere. It's not a stochastic event. This is also a big question of astrobiology. We can discuss this more tonight if you want to. I'm going to stop here to let you talk a little bit about that too. But these are huge, huge paradoxes.
Okay, merci, Nathalie. The question you ask is really the right one. I mean, all what we say has to do with the definition of life that we get. In the same way as the Earth as a planet. Depending on what you call the Earth, there are billions of Earths, there is only one which is ours. It depends the accuracy to which you measure things, you characterize it. If the planet Earth is only something defined by a size, distance to the sun, there are billions of them. If now you try to understand what is on your back here, something with a very thin atmosphere, with half-half clouds, with all what we know now, and with in particular the fact that we are discussing now here on that planet, then you try to understand the reason why it became like that, then the definition of Earth is entirely different. And then you will, and we could do the demonstration I think tonight, but I think we are close to agree on that, it's impossible, given the number of billions of planets in the universe, observable universe, it's impossible that we have the same sequence of events that went to the same planet in which we are now. So the unicity of Earth is just a matter of the definition of Earth that you had. And I would say that for life is about the same. In the antiquity, there was a word in early Greek, for example, they said zoe, but the same in Latin here, that there was a word from that. Why? Because there was an obvious reason for them to say a stone and a tree are different. And they said, let's define the tree as belonging to life, and whatever, all the rest is non-life. And it's true that in our way of thinking and way of experiencing the things, we love binary things like life and non-life. The problem I have with that, the problem I had with that a few years ago, it's not really far away in my past because I'm not a biologist and there was no reason to say anything concerning life, really, except that we are searching for life on Mars since a long time. We build instruments to try to see, and I had to ask myself, what are we looking for? What we would like to find that? And I hope that tonight we will try to go back to that question. The problem I have with this question of life and the binary between life and non-life, that you are forced to try to define a principle of life that would exist, and in that case, that might take other forms somewhere else. And I tried to do that. I did that with tens of biologists, well known for most of them, to try, we sit together around the table and I said, what do you call life? And if you put 5 biologists, you will have 6 answers and they will start to fight. Essentially because there is no definition of life which is acceptable now. Not because there are too many, it's just because they are not acceptable. If you, I don't know in Italy here, but if you open any book in France, and in English the same, on what is life, you will have things that I think are fundamentally wrong. Self-reproduction, self-catalysis. Well, the principle of life is not to be self at all. It's not autonomous. When you cut the connection between life and the rest of the universe, of a tree, for example, with no roots and nothing to see the sun, it just dies. So life, per definition, cannot be consistent in autonomous in any case. So there is a real problem with that. But the essential problem to me is that if you want to define life by a principle, which is impossible to find, but still, supposedly it is, I found one personally, which is in my book, but it's difficult. Then you have to assume that at a given point, you go from inert, non-living, to life. You have to create, emerge this property. And to me, it's either creationism or the spontaneous generation, like Pasteur 2 centuries ago, 1.5%, to 20 years of his life to try to demonstrate that you cannot just autonomously generate new things out of nothing. So that was the problem. And this problem we can discuss later tonight, or today for you, it has a lot of consequences. If it's just a matter of semantic, we don't care, really, and I wouldn't care. But the fact that considering that life is a concept, acceptable, and there is a principle of life that you could find somewhere else, not only it drives some research and missions, space missions, that I consider will bankrupt. They will never find that because you cannot define what you are looking for. But more than that, it assesses something, it reinforces an idea which is a wrong idea. And so I consider that biology is at a stage where physics was 50 years ago, and very often I give this example. When Newton said that the same force explained the apple to drop and the moon to turn, I think this guy is genius. And he has the formula that explained that. And then Rutherford with electron and the protons. Up to recently, 50 years ago, when the physicists said, well, how does the electron know that there is a proton here? How does the apple know that the Earth is here? There should be some way of putting information there. And the notion of force has been overcome, dépassé in French. We had to go further. And normally now, you should not be even teach the notion of force because you have to have an exchange of information, and that's why the boson have been created as a concept and then found, as you know, at CERN essentially, to explain that gluon and Z and W exist. So I think that for life, it's the same. And it has, so the answer to your question, what you consider life is very difficult. If I had to formulate now my answer to your question, but it has a lot of things to be discussed before, it is the very specific carbon chemistry evolution, which exists everywhere. But all the carbon chemistry evolution will be driven by the contextual, by the context, essentially, by the contingencies. You will have a sun putting something here, and the chirality will have some excess of chirality. You will have this rather than that. And when these very specific early grains, cometary grain that we show, for example, with Philae and Rosetta, entered a very specific water, because water per se is not habitable. If you put a fish in an aquarium where there is pure water, it dies. What is important is what is in the water. We don't know what was in the oceans of the Earth when these grains came. But what is obvious that given the specificities of the organic grains before, and what were the specificities of the water at that point, it oriented the evolution of the chemistry in a given things. And all the evolution, and I have some charts showing that eventually, but is really a sequence of bifurcation like that. And the bifurcation, at each stage of the bifurcation, the context will favor one rather than the others. So life is the pathways that the organic chemistry took on the Earth, given the very specific evolution of the Earth. And so life, to me, cannot be elsewhere because it is intimately coupled to the evolution of the Earth. The Earth is unique, as we said previously. Life is for the same reason. But it doesn't mean that in the solar system with the same ingredients, organic grains coming from the same comets, on Mars, for example, we will not learn essential things as to the evolution of these grains in an environment which was different from ours, because a little more iron or molybdenum or whatever in the water will change or will favor that evolution. So we will see that, I hope, both in Mars or in Europa or wherever it is. And out of these, we might extrapolate to what were the oceans on the Earth that led to us, which is impossible to find, of course, on Mars.
Yeah, if I can just comment something on what you said. I think, of course, Nathalie is a biologist. She cannot say that life does not exist, right?
So, no, actually, I am not. I am an astrobiologist. Doesn't mean that I am a biologist.
But I want just to conclude. And Jean-Pierre is saying that life is very much related to the conditions. So you can have so many different forms of lives. You cannot prevent them. These are very large nonlinear problems, we say, and very sensitive to perturbation and so on. You will never know what is going to happen. So you can have a lot of life in the universe. But Nathalie said you have 120. So are this 120 one of the possible solutions of your?
No, and I agree. And I agree again, you know, with what Jean-Pierre is saying for most of it. First, I'd like to make a few comments. First, if we are looking for the exact replica of the Earth in the universe, I have to agree with Jean-Pierre. This is very unlikely to happen because we are looking at conditional probabilities. And for that, I think definitely this is unique. On the other hand, we cannot suggest at this point in time that the Earth is the optimal or unique way to produce life in the universe. So I think that the different models that are going on right now pretty much agrees when you're looking at the four-corner hypothesis for life, which is to say that life is abundant and intelligent life is rare, or life is rare, intelligent life is rare, and etc. You do the four corners. Right now, we cannot say one thing or the other. Everybody agrees pretty much to say that simple life would be abundant, and that intelligent life, complex life, might be a little, well, a lot less abundant. But so we agree that Earth is unique. As far as the definition of life, I, for one, think like they are in definition, they are descriptions, and we're trying to do our best with what we have. And I am not even sure we need a definition of life. Where I do agree with Jean-Pierre is this notion that there is living and there is non-living. And we are thinking in binary terms, and this is seriously limiting our ability to explore. And I've been adamant with that when I'm talking in astrobiology conferences, or even at headquarters when it comes to discussing with NASA, because at this point in time, we're just looking at the kind of things we know. We cannot recognize what life is, so we will never have a definitive answer. We would have to have a rabbit jumping in front of our rovers to make sure that life is present. So there are limitations to that, and I would agree that I see life more as a continuum rather than as a stochastic event. But to say that it's something that astrobiologists are not aware of, they are aware of. Right now, there are lots of research going on trying to figure out if we are looking at a continuum or if we are looking at a stochastic event. So these are the kind of things that are important point right now. The conditions of Earth, the circumstances of Earth, they are unique. We all agree on that. But where is there to say that there is no life elsewhere? I think that it's much too early to say that. And this is where numbers and probabilities and different worlds and different life might come into it. And just a last point before we move on to something else is, as far as looking for life on Mars, Jean-Pierre, we haven't. We haven't. The one attempt that was done was by Viking. And just because you, just like me, are very aware that to have life, you need to have a co-evolution of life and environment. The issue with Viking is that we didn't have any notion of what the Martian environment was at the time when the experiment was performed. So hence, 40 years of trying to learn about the geology, the mineralogy, the climatology, etc. And now Perseverance is looking really for the first time, and I would say in what I think are very feeble ways, and I have been very vocal about that. I don't think that we are looking for life on Mars the way we should, and I said that many times. But the fact is that Perseverance and soon Rosalind Franklin, I hope, will be looking for life on Mars. So it's not that we have been looking for a long time. As far as looking the right way or the wrong way, I am with you. I don't think that we are looking the right way on Mars, but that's a different debate.
Yeah, okay. Yeah, several times you said, okay, rare, it's rare and so on. I would like to go back to this question of, because that was the idea, whether it's a probability stuff and whether it makes sense to think that because we have billions of planets, there might be some life elsewhere. I would like to come back to that. First of all, it's in the antiquity, as you always said, it's always the question that you men ask. I'm not sure really that the people 3,000 years ago asked themselves whether there is life over there. The few people that wrote that, they took one assumption. Like Epicurus, for example, the assumption was the universe is infinite. And it was just driven by that. If there is an infinite number of stars, and he considered probably of worlds, so he said worlds, so planets. If there is an infinite number, of course, you cannot avoid that there might be some in which someone says exactly the same word that I'm saying now, and people laughing exactly the same way now. That's true. That's the principle of the infinity. But, and remember that after the creation, 2,000 years ago in the Bible, when there was no infinite world, and so there was a single one created, 6 days with human beings. It has been terrible for the people to react against that. And the first who really did that was Giordano Bruno, who paid by his life because he was burned for that. And when you look at the trial of Giordano Bruno, it's very interesting. It's not very far from here. It was in Venice. He was arrested there. And he accepted to all what he has been proposed to abjure, to say, okay, I said that, I can say. The only thing he didn't want to come back to is the question of infinity of the universe and the fact that there is life elsewhere. And that's the reason why he has been burned. It was the 17th February, 1600, 33 years before Galileo trial. So again, it was this question of infinity who led to that. And it's very strange that now that we know that the observable universe is not infinite because of the evolution, which has an age, and so there is distance beyond which you cannot have the information from because the information didn't have the time to get to you. So we know that there is an finite universe now. And we play with the semantic idea that billions of billions, because we know now, and with, as you said, constantly with Kepler, we know that essentially all stars have planets, and there are billions of stars in a galaxy, billions of galaxies, so billions of billions. We play with that to say billions of billions is infinite. And it's true in English, it's true in French, the milliards de milliards, milliardi, milliardi, and so on. But it's not true. We are 10 billion people on this planet here. We'll all know that you can make as many kids as you like. There will never be two kids similar. Why? Just because you know that 2 times 10 to the 23, which is the number of chromosomes in one single spermatozoid, multiplied by 2 10 to the 23, 2 times 10 to the 46, is much more than billions, and we multiply that by the number of people on this planet, it's much more than billions of people. So people they accept this idea that with probability, billions of billions is not sufficient to duplicate things.
No,
but for life, we do not accept
I will
that.
object to that.
I'm sorry?
I will object to that just to say that we are not looking for an exact replica of the Earth. One point that I would like to make is that when we say Earth-like, never ever meant
So
like
what is the definition of life that you will use to say it's not a replica, but it has a property of life?
We don't know, that's the problem. And this is why, you know, what I am always saying. How do we search for something we don't know? This is why I am also very concerned about people who are telling me life originates somewhere. I prefer to understand what life is about rather than trying to understand where life originates. I think that I'm more, at this point in time, attracted by biophysical models that are using physics and trying to understand this transition from what we call living and non-living. I am not subscribing either to this. I think that we recognize something to be alive just because it becomes alive for us, not because necessarily it's not alive before. I think we just have, at this point in time, some limitation to that. I am not disagreeing with you on a number of things. The only thing is that I'm saying I'm not looking for a replica of the Earth. Again, Earth-like doesn't mean like the Earth. And we are looking at possibilities that a type of life, which doesn't have to be life like we know it, or human life, is elsewhere. So that would be my only reservation. Other than that, I think that the two of us agree on more things than we disagree. It's just that I don't see why life and the living should be limited to the Earth model.
Sure,
at this point in time, I cannot say it's true, I cannot say it's not true, but I think it's the same for your thesis.
But for example, what we consider life, which is life in the world we know here, we have this production of the functionalities. We know that there is an heredity of functionalities. And we know now the molecules involved there, like ribosome, for example. When you discuss with the people in biology to ask all the pathways from simple molecules to get to the ribosome, and you modify anything there, like the some of the NH2 that will move off one of the DNA, or anything, one of the nucleic acid will be another one, and so on. Immediately, you don't have the property that you consider fundamental for life on Earth. So this is the point. So it's not that whatever you put here, you will modify something and you will still have the same function at the end. This is not true. And I think that that's the basic reason. Finally, the reason why I'm so, maybe too much actually, aggressive against this idea that there is life everywhere, is that we consider, we cannot avoid the idea that if you consider that there may be not replica but something else, which would be called life, that you would accept to call that life, it will have one property that life is here, and I do not see that feasible at all. That's the point. I do not. But again, there is a lot of carbon chemistry, very complex molecule, even probably much more complex than ours. I'm not saying that we are the only one here as a complex molecules. I'm also against, for example, the idea that evolution goes from simple to complex, and life is in that thing as a step in the complexity. Normally, the people that put an arrow there put the brain of the human beings over there. I am against this idea because that's really ideologically biased. And we know what, at a given point, it was necessary to demonstrate that there is a scale of complexity in which mankind has the top step, which is probably not the case. So the same with life. Again, in my lab, for example, as many labs, there is people working on exoplanets, and they discuss the question of habitability. And in your book, there is a lot of things about habitability, as if it was a concept, an accepted concept. It's not. Habitability is the possibility for water to remain liquid. It has to do with the temperature. But the temperature on the Earth is not really a matter of the distance from the sun. It's a matter of the composition of the atmosphere, the greenhouse gases. And as you know well, I mean, I'm not, everyone knows that, but these greenhouse gases have to do not with the sun, with the radioactive content on the mantle, and that has to do with the history of the planet and so on and so on. So you have to enter a lot of different parameters, and that has to be taken into consideration. So when you said that we're in the habitable zone, go ahead, I'm sorry, yeah.
Yeah, no, that's okay, Jean-Pierre. Again, we agree. And when we say liquid water, we're not saying this is the only requirement. This is the requirement that if you don't see it, it's a bad sign for life as we know it. Here is an example. as you say, Mars is in the habitable zone. At this point in time, there is no liquid water at the surface. So there are a number of other reasons for that. It's not because you are in the habitable zone and we see liquid water on the planet that we say that there is life on it. But this is a place where we can start to look. And we know that we need much more than that. You need water, you need energy, nutriment, source of carbon, etc. You know that as much as I do. But this is the first thing we look with respect to our own model. Because if life is not there, then forget about it. If it's there, maybe there is nothing on that planet. But if it's there, maybe we can start to look. And also, you know that there is a lot more to habitability than just being in the habitable zone. You can be outside of the habitable zone, and this has been demonstrated by work in extreme environment and also by planetary exploration. There are places in the outer solar system where you do have the condition for what we call habitability, or at least for the conditions for chemistry to start something, and they are outside of the habitable zone. So to your point, not all the planets that are in the habitable zone that even have liquid water will have something starting in them. But at the same time, there might be other environments outside the habitable zone that have the good ingredients to get the chemistry started. Where I will join you is that we are unlikely to evolve something very complex on a small moon, for instance. But that doesn't say that maybe the chemistry of life cannot get started there.
Yeah, so Nathalie, I see that it is difficult to get an agreement for you both on this, but yeah, it's also in the question mark of this discussion. Is a rule or is an exception? Yeah. I think probably Nathalie thinks more that can be considered a rule. For you is more an exception. No? So if I want to change, no, it's not.
I wouldn't say a rule. I say, and again, I don't say how many times I'm going to say that I agree with Jean-Pierre on something, because we agree on a lot of things, in fact. I would say that each world is a unique planetary experiment. So no matter what, you cannot talk about a rule. But what I'm saying is that you have so many ways of combining organic molecule, etc. And to go back to your discussion with your biologists, we do have experiments here. One of them is the Genesis Lab, which is reproducing early Earth and doing this in hydrothermal setting, and very, very fast. They see things showing up like the ancestor of cell coacervates and things like that, and even things that look like the beginning of RNA. So I'm not even sure that it's so difficult, but anyway, I'm going to leave it here because we might want to move on to this discussion.
Okay.
Maybe please. Just a joke for habitability. If it's habitability, without being inhabited, if it's habitable but not inhabited, something is missing. If something is missing, it was not habitable. And that's exactly the point. To be habitable, you don't need water. You need water plus all the ingredients in. And the beauty of what we're building now, in particular with ExoMars, and I really hope that ExoMars will see really Mars as soon as possible, is exactly that we will see what there's different ingredients, probably the ingredient that goes from the cometary material there, but in different water there, with a little different ingredients in terms of catalyzer or whatever, will probably make the carbon chemistry evolve. I hope we'll see that. And in principle, ExoMars is really designed to make that happen. So, and uniquely, because Perseverance is not. So we can do here in Europe something that for the moment, Perseverance we cannot do, and I do not know what will be the future, but even for the MSR, it might be a problem. I hope that with ExoMars, we will demonstrate that this carbon chemistry is very efficient with some of the same ingredients, which I think are already some excess of chirality in the grain that came really to us early on. They went there, and it's interesting to see, because we'll be able to characterize the water in which evolution took place because we have the minerals that drove the evolution there, the different alteration products. We will see, I hope, the possibility of the pathway of the organic grains, not to go to a ribosome or whatever, that's not what I'm looking for because it's out of the scope, but to which direction it goes and what should be the water that was present on the Earth 4.3 or 4 billion years ago that went to something different, like, for example, polymerizing some, not the lipids, but some of the material that was in the organic grains from the comet, let's say, to make these vesicles out of which the water could not destroy everything because water is also lethal, as you know. So that's exactly, I'm not saying that we should not continue the space exploration towards understanding what life has been on the Earth as pathways, but it's not to say that we will find there, mosquitoes or I don't know. No, we will not. And it's not what you call the simple thing. It's not a matter of simple or complex. I consider that a lot of carbon chemistry might be complex, but it will be different from the one that we have here that led to us. And that's the beauty of the space exploration.
Okay, so
I have another joke for you about inhabited and habited. The fact of the matter is that we can say, the reaction is to say, does inhabited mean inhabited? We say, no, of course not. But you know what? You and I, we still have to demonstrate that's the case. And that's the beauty of it.
Okay, thank you. I think the audience has got your points on these very fundamental questions. I don't know if someone would like to make some questions on it. Otherwise, we can change a little bit, at least the points. Is there, okay, please.
Yes, Jean-Pierre, you say something which was strange for me because I heard a scientist saying that he has made some modification on an ADN of a living organism, and this organism survive and evolve. Yes. It was a chimera, something like that. So you can change something on ADN and keep the function working. So it's not the same ADN, but it works. So there is an exception.
I just wanted to ask, you were speaking about probability, and I wanted to say, what about the prediction that Enrico Fermi did 70 years ago about the fact that if there is some form of intelligent life that can communicate with the same physics that we know, if it actually existed, it would have already made some form of contact with us.
Yeah,
Nathalie,
that's
go ahead, yes.
the Fermi paradox. I'm going to shock a lot of people here. I am not a fan of the Fermi paradox, to tell you the truth, because I really think that it lists on all the psychosis and fears of humanity about, it shows more who we are rather than try to understand why somebody might not be communicating with us. There are a number of reasons. The reason why I actually still appreciate the Fermi paradox is because it gives us an intellectual framework to think about those questions. But let's imagine for a moment that you have an alien civilization. Well, you have distances, you have a number of reasons. Is life a generational phase in the universe? You only need to be 200 years apart, even in the same neighborhood, just to not being aware of there is somebody. Remember where we were 200 years ago? We were using boats and horses. So there are a number of reasons, but we need to be humble too. I think that it may be that the way aliens think about things have nothing to do with our way of thinking in the first place. And the other one, it might be more down to earth. I think we still need to be even more humble because we are a young technological civilization and scientific civilization. And we are far from knowing everything about how the universe works. And so if you have an advanced civilization, maybe we have messages all over the place we cannot recognize yet. I don't know that. I cannot prove that. But let's say that I wouldn't stay too hung up on the Fermi paradox, but definitely a good way to start.
Okay, I fully agree with that. One more point maybe for that question. Like, I was not present when Fermi said that, so I don't know exactly the context. Well, we all know the context, he was drinking and so on, but
that may explain.
With colleagues, but we don't know exactly what if that. But there is something that was pregnant at that time and still is now, which I am strongly against, that there is a determinism in the evolution. When we speak of life here, it has nothing to do with human beings here. I think that no one would express the idea that even from what we call the simple things, and I do not consider that bacteria are simple, that's not the case, but still, the evolution necessarily goes in a scale like that, by steps, to human beings, and then civilization, and then intelligence, or whatever, as something with an arrow like that. I think it's still pregnant now, unfortunately, but fundamentally wrong. I think that you should not consider that as soon as life starts, it will necessarily lead to who we are here. It's, no, again, the evolution, and if you believe in, not believe, but you understood Darwin, what put life in a given pathways, in a diversity of pathways, is really the context here or there. And it's we are just the result of that. And if there had not been the geological evolution of the east of Africa 20,000 years ago, we would not be here either, right? So we have to be very cautious putting arrows like that. So I'm not saying that Fermi did that, but if he did, of course, we are again this idea. No, we are really thinking here of the possibility for organic matter to necessarily go with something that finally leads to a ribosome or whatever, something that will conduct to what we consider the living property here, which is the heredity of the principle of the functionalities. And that, because if not, you take a cloud of gas and grains, which will form a star here and planets around. By the end of that, it will be back to stars, and because it will go back to dust, and dust will remake stars. And the Earth the same. But the remnant of the Earth will never produce a new Earth. It will produce a new planet, that's for sure, but not really the Earth. I mean, certainly not the Earth, because again, the Earth is a result not only of the condensing of a cloud, but a condensing of a cloud in very specific conditions that draw different things that led to, okay, that's what I said about the diversity. So that's the same for life, I think.
Oh, sorry. So, thank you. Okay.
Hello, I have a question. What should we do if we really define life on Mars, but in the future, maybe after many years, we discovered that it was originated from bacteria brought maybe on board by our landers?
Okay, to me, the real question is, what shall we do if we don't find anything on Mars? That will be a very complex question, because there has been so much investment based on this idea that there is life on Mars and we have to find it, and if we don't find it, it's because we are not capable of finding it. That's really the problem. But now, if we find what we call life, I'm not sure that what we will be able to define as life, and as you know, there is different possibilities to mimic that. The very first question is, are we sure that we didn't bring it there? And that's a real question. I mean, planetary protection, we are not going to discuss that here, but we have to ensure that whatever we find there is really something that we have not brought from Earth. And that's not a trivial thing, frankly speaking. And all the people who are really dealing with space missions know that even now, we have, I discussed a few hours ago, even Perseverance, you know, on his wheels, whatever, might have brought a few things from the Earth, like spores, or I don't know. Are we sure that these, supposedly we find some spores in the material back from that. How shall we know that it was not brought by Perseverance itself? So that's not a stupid question. But again, the risk is very, very limited that we find a fly or a fish or whatever there that will mimic our fishes and flies and say we have found that. So we have to understand that whatever the answer will be, including that we have not found that, but we have understood that the question was not well asked, and we have new questions on the process by which carbon chemistry evolves, it will be a success. But the success should not be considered only if we have the right answer to the wrong question.
I would just add to that I think that Mars doesn't care how much money we are throwing at it to find an answer. If the answer is no, it's no. But where I agree with you, it's going to be really tough because the negative answer is always the hardest one to prove. When do you stop searching? When do you put a fence and say, Mars doesn't have life, so let's move in? This is something I also right now fighting a little bit against, because human exploration, as soon as you have human on Mars, you will have life on Mars. I'm not making a joke here. Humans are microbial factories, and conditions under the surface of Mars are such that they are not that different from the Earth, and microbes, extremophile, could survive out there. In terms of finding fishes and fly, I'm afraid that Mars never had enough resources to do that. So the question of planetary exchange is a good one, though. So what could have happened? Maybe that Mars seeded what made life on Earth, or the other way around, or we find some terrestrial materials. There are three possibilities. Mars doesn't have life. Mars has life, and it's a second genesis. I don't like the term, but it is what it is. And the second one, and the third one is that it's a shared genesis. So I think that the issue would be with the third one. If we have any type of family relationship with life on Mars, that might become a problem when it comes to forward and backward contamination. But in terms of finding terrestrial life on Mars because we brought it, I would say if the start of life is different on Earth and on Mars, life co-evolved with its environment, so we might be able to tell them apart and know that's contamination. Now, the risk of contamination as far as what it can do for terrestrial life and for Martian life is a different question.
Yeah, I'm sorry, I'm coming back to the definition of life. Sorry, I'm late, but shall I dare to propose you a definition of life?
Oh, that's okay. That's only 124th.
Okay, fine. Okay. And it's something that comes from some kind of education I had in information theory and thermodynamics. Okay?
Yes.
Could we define life as having something that somewhere is increasing entropy?
So this is what, Schrödinger worked on that in 1942 and started asking those questions. And there are a number of new theories right now, and young biophysicists who are working on that question. And they are saying that life is the inevitable result of thermodynamics. So this is, heading in the direction that you are saying. So that they are the best way to fight entropy. So this is where we stand from the standpoint of biophysics right now. For me, I like that aspect of it because, and this is where, Jean-Pierre, I really want to talk to you at some point, because I think that you stopped in your book where I really would like you to get started, which is to take this to the very beginning. Biophysicists used physics in the universe to try to explain the principle and the process of life as a universal thing. And so I don't have any problem for you to try to explain life from a thermodynamic standpoint. And also think that maybe we are at the point in the universe where life, as we understand it, is becoming possible because those elements are here, because the universe is at this stage. And maybe it won't be possible in a few billion years from now. I don't know about that. But this is what biophysics has to say. And Schrödinger said it, and Jeremy England is saying it again, and he's talking about the inevitable theory of life as a universal principle.
Can I say a word concerning the entropy? I'm always cautious with this question because thermodynamics, as you know, has to do with isolated system. Life is not isolated. So you cannot say life goes in either direction, plus or minus for the entropy, without considering the entire system, which you put the sun, airs, and whatever else. So you cannot define the life without, which helps life to exist and to develop and evolve. And so if you take all that together, I think it's not true that life increases the entropy. For any photons arriving from the sun, life or whatever, you too, put 20 photons infrared in space. You increase the entropy of the universe doing that. So it all depends on the system you consider. And that's why all the people who have tried to define life by that sort of physical things, in particular in the 19th century, when they considered that life was again the physical law because we go to order, while normally the second principle tells you that you have to go to disorder. So be cautious. To me, we should be very cautious defining what you call the isolated system, in which when you said there is a difference between a rock and a tree, the tree cannot be defined as such. The tree has to do with the roots, with the leaves, with whatever, and what it takes out of that. And if you take the entire system, the question of how the entropy of the entire system evolved is much more complex. That's my feeling.
But Jean-Pierre, I think you would be very interested in looking at Jeremy England's work. It's been some interesting modeling you would appreciate as a physicist.
Hi. So going back on Mars, actually I've got two questions, probably more for Nathalie, but of course Jean-Pierre, jump in if you want to add anything. So first one about Mars, Nathalie, you said that concretely speaking, we have not looked for life on Mars since the Viking missions. What do you think then about the storytelling around Curiosity and Perseverance missions? Because it feels that the storytelling tells we are looking for life
Curiosity
there.
And which one? I'm sorry.
Perseverance, the last two missions.
Yeah.
Okay, and I can keep the mic for the second question.
Okay, so Curiosity was a, so let's start with Perseverance. Perseverance is a biosignature seeking mission. So this is the one I would say is really restarting the search for life process. And Curiosity was a follow-up on the fact that we had demonstrated the conditions for habitability in early Mars with Spirit and Opportunity. So there was a new payload to look into more into organics and into environmental, but it was still a habitability mission on steroids. So Perseverance is different. Rosalind Franklin will be very different. So yeah, what's the other question?
Okay.
Sorry, so the second question was about the Fermi paradox. So you said we are a young civilization and we should be humble, but still we are a civilization capable of detecting technological signals, some of them at least. So what's your favorite answer to the Fermi paradox, not in terms of not having received a visit, but not having detected anything and that the universe is silent? What's your favorite answer?
To the Fermi paradox, I guess, you know, I don't have a favorite answer with the Fermi paradox, to tell you the truth. There are answers that make more sense to me, like the fact that we can be separated only by a few hundreds of years and being right next to each other and have no idea, although this is going to go away now, especially with the space telescopes that we have. We are not only looking into a radio signal or optical SETI at this point in time, we are also looking at the possibility of technosignature, such as, let's call it pollution, for instance. So I would say that, you know, things that make sense to me are distance, are also the fact that alien might be very different than we are. And that's, you know, I'm not a fan of the dark forest and all of this kind of thing. It's very, very anthropocentric.
Okay,
yeah.
Please, yeah.
Yeah, so I'm also a physicist. I'm very interested in biology, and so it's quite interesting to hear this debate where we don't have a biologist in the room. But and I like very much what you said, Nathalie, that we have to stay humble, and we have also very limited knowledge of what were the different steps that led to the RNA world. We believe that it has a so what was before the RNA world, which we think was actually a defining moment. Even more maybe that creating DNA. And so when we search for life on Mars, shouldn't we also be humble and go step by step? So we had the search for water, now we search for carbon, we barely detect it now, it's a limit of detection with perseverance. So we could search for complex organics, we could search for signs of metabolic products. So what would you see a kind of humble, scientific step-by-step approach to really advance in this process of searching for life on Mars?
You're asking me or Jean-Pierre?
Oh, well, let's see if you agree on this one.
Well, I mean, we are. I guess we are. And the truth is that, you know, as sophisticated as our rover and our payloads are, they are still limited. We're still limited to what we can do in situ, and that's too bad because I am of those who even while I'm making you know, field work, I know that samples are going to be modified when they are sitting for a long time at the surface of the planet. They might be modified by the transit, so we should be able to analyze them in situ. But bringing them to Earth will help us have them go through more complex analysis that we couldn't do on Mars. But I think that we're doing this step by step. I think we have been looking for habitability. We are looking now, well, presence of carbon, presence of organic molecule. We have them. The issue is that you don't have any biosignature that is truly uniquely related to life. Signs of methane or sign of isotopic carbon like we have the C12. All of these things can be related to life. They can be related to something else. All we know at this point in time is that Mars has signs of still having magma moving. It still has signs to having water moving. And so Phoenix also discovered some potential for nutriments back in 2005-07, I don't remember. So I think we are doing the step-by-step approach. What we cannot do and might have still difficulty doing is the complex analysis, and that's why we are bringing back samples on Earth. Jean-Pierre, I don't know if you want to add something to that.
Yeah, I think, Jean-Pierre, you have some slides to show.
Yes,
right?
maybe I have prepared a few slides. It will be very quick just to summarize my idea there. But just to follow on what you said, step by step, to be humble, whatever, I think we all share that. I mean, that's obvious. We know very little as compared to what we will know or they will know in the future. That's obvious. The point I want to make is, I wanted to make it the following. First of all, when we make a mission, is to answer a question. And the success is, in general, that we don't answer the question, we show that the question has to be modified as a question. When we make Rosetta and Philae, we had this idea to try to understand what are the material there, and that ice would be dominant. The mission, we discovered that there is only 15% maybe of ice in a comet, and more than half of the mass is in organic grains, really grains, millimeter size. And that changed to me a lot of my ways of thinking, the evolution of the carbon chemistry in space, because these grains, I'm sure, are different from those that are present in another thing. So yes, we have to go step by step, but we have also to be open to discoveries. And I am sure, really, that ExoMars is on that class of mission, that it has been set for good reason to answer questions, but we have to get prepared to the idea that we will never get the answer to these questions because they are not well asked, actually, but they will open a huge new field of research that will modify entirely the idea that we have, in particular, of the carbon chemistry towards life on Earth. So that's the reason why I'm just preparing ourselves. We should not really consider that if we do not find what we thought it was 20 years ago, even more than 20 years ago, as the reason why we would do ExoMars. If we don't find that, it's a failure. No, it's just because we have modified our mind. And if what we have on board now is capable of asking different questions, that's a real success. So
I agree. Science is here to articulate better questions, not necessarily to answer things. And as far as the no question, again, you know, this is the hardest one to put a limit on. And it may be that Mars doesn't have life on it. And, you know, Sagan actually addressed that question. You see, if we find life on Mars and then we have 2 planets in a system of now 8, then that tells us something about, you know, the ability of life to get started on planets. If we don't, we'll finally find a place and a limit to what life, at least as we know it, cannot deal with. So again, you know, we are not to say, oh, you know, we will find life on Mars. I think that we go there because this is the closest environment, that this is for us the best school to learn the limits of what our own life can handle. And if it's there, then, you know, good on us. If it's not, good on us too. We'll learn. That's science.
Nathalie, thank you. Have you prepared a few slides to show? Because that's a good time.
I was not asked to prepare any slides, so go ahead.
No problem.
Okay. Maybe.
Sorry, Jean-Pierre, can I just
sure,
add something? Yeah, okay. I think, yeah, the problem was definition of life, of course, and we did not get a complete agreement on that. Okay, I was asking also about the definition of universe. We know that so many think that we not only have this universe with stars, planets, galaxy, we can have so many other types, so we don't know if we investigate this type of universe. You know, this Friday, here in this room, there will be a talk about the possibility, when we finish our event, if someone is some interest, someone is going to come and to describe the quantum interpretation of soul. Yeah, so I don't know if we have to, I don't know if it is a solution, you know, to our problem. So we talk about soul. It's not in a religious manner. Yeah, he's a physicist. It's not, he's going to talk about quantum. Okay. So this is something, yeah. But I think many in this room, before to give you the floor for the presentation, many in this room know that Nathalie has tried to find different type of life in, you know, complex, difficult place in our planets, the deepest part of the ocean, also the highest part of mountains. And I think I got some messages from mostly from the students about the possibility to find any kind of this life in the solar systems. And the question is there really a possibility when we will make this with our means? I don't know if Nathalie is there.
Yes, sure.
Okay.
Why? No, I'm here, but it's funny how it always ends up by people asking when we will find something. Yeah. So you know what? As a scientist, I don't like so much giving numbers. I will take the easy way out, saying that our generation is probably the closest than we were ever before. What I would say is that in the past 20 years, we had something that has changed in the scientific approach. You have to have a reductionist approach when you are, you know, looking at specific processes, trying to understand narrow questions. Life and life in the universe doesn't Well, you can do that, but the beauty of astrobiology is that it brought people like Jean-Pierre and myself. Jean-Pierre and I, we have different backgrounds and look at a question from different perspectives. And this is from this kind of debate where we don't necessarily agree, but where we agree on one thing, is that science is not about ego, it's about question and articulate better question and look at data, that we're making progress. So I would say that the more we get people together from different perspectives, different disciplines, and not necessarily agreeing with each other, the faster we'll make progress. So I will leave it here. Frankly, I'm apparently more optimistic than Jean-Pierre. I would say, I'll give you a number just to make you happy. I'd say within the next 25, 30 years, we should have something.
Okay, so please, Jean-Pierre, go with your...
Okay, we'll go with that, and I need that. Okay. Yeah. Now, we'll not answer the question of when we'll find life, because I think that the optimistic way is to demonstrate that what we will find, what they will find, because there is a lot of young generation here, and actually the colloquium is made really for the young generation to take the lead now in the space exploration. They will find other way to profit by the space exploration to solve the challenges that we have on the Earth now. So, I prepared a few slides that I thought might be helpful during the course of our debate, which was not the case. Just to summarize by one or two at the end of what I consider the take-home messages. To also answer the question of step by step, it's amazing how quickly we change some paradigms with the space exploration. And this, which is put right here, which is that the plurality of worlds was really the dominant one up to the 80s, typically, as after the Viking and the Voyager mission at Titan. Rapidly, it was obviously that we have to change these paradigms toward the diversity, and that, I think, is fundamental. This plurality was, again, based on the conviction because the universe was considered infinite, which is not the case. But up to present, a lot of people consider that it's close to infinite and there should be life elsewhere. And the debate tonight showed that. Now, this change of paradigms is really fundamental, I think. And we have not yet taken the measure of what it means. It's really space exploration who proposed that diversity as the key, really, to consider. But both the diversity of the humans on the planet here, or the diversity of the evolution pathways, and characterization of this extra. We have not discussed that, but as you know, the exoplanets, which have been found for almost 5,000 of them now, it's a fantastic discovery because it was proposed in the 18th century again as a normal way of forming stars and planets around, so it has to be demonstrated, validated. They did that. But to me, the most important thing is not really the validation, which of course was a reason for them to get the Nobel Prize 3 years ago, Mayer and Kellos. No, it's that none of the extrastellar system that found correspond to what we thought would be found, because we have understood that diversity now is in the formation of the stellar system themselves. And so the diversity expands from a given solar system to all stellar systems. And just to remind you that the first observation of these was really that one to me. These observations on the way to Titan by Voyager, it was in 79, 2 times because there was 2 Voyagers, they fly by the Galilean satellite. And from the discovery of the Galilean satellite in 1610 by Galileo, up to that date, essentially we didn't make any progress in characterizing the satellite. They are too small on a telescope plate. It's really by the flyby that we observe these, which are completely non-expected diversity. We have 4 objects formed at the same time, made of the same material, at the same point in space. And when you look at them 4.5 billion years ago afterwards, it's amazing. And as you know, the EO, the last one on the right here, the guy who proposed that we should see something absolutely astonishing, he proposed an article on that, which has not been accepted as a paper. It's only Science that 2 weeks prior to arrival said, well, we'll give him 2,000 words just in case. He suggested by a computation that it would be the most volcanic object in space, and he was right. Anyway, so that's fantastic because that's exemplary of the diversity that afterwards, starting in the 80s, has been the case for all the planets. But again, that's at all scale, as I said. But that's the reason why Earth is unique, because the more we characterize it, the more we understand that it's different from the others. The 4 Galilean satellites, as you know, as just satellites, the moon around Jupiter, they were the same. But when you look at them precisely, they are different. But what is key now is that now we have entered a new era of space exploration, that not only we observe the diversity, but we start to characterize the reason why this diversity is there. We start to decipher the reason why the Mars is different from the Earth, from Venus, or whatever, and why the different stellar systems are different. So we start to understand the processes. And this is absolutely amazing and fundamental for me, that again, the determinism that proposed that from the Big Bang you have a simple to complex uniform evolution and that everything has its place there. You understand that although the law of physics are deterministic, because of the chaotic behavior, I'm not even speaking of the quantum physics there, but just by the chaotic evolution of the fact that you never can have identical initial conditions, you end up with a lot of the possibility for contingencies to take the lead here. And we know now that migration, for example, I think I put here, I have no time, of course, to discuss that, but now that the people are convinced that in our own solar system, Jupiter and Saturn had some migration. They never were always there, as we thought even 20 years ago. No, they migrate, very likely, but they're very specific migration directly connected to the structure of our protosolar cloud. Jupiter, as you know, went toward the sun, essentially emptied everything. That's why I put that white. But then Saturn went, and the ratio of mass during Saturn and Jupiter make them living toward the external part of the system and left confined disk out of which the 4 inner planets formed, and in the right mass ratio. That's why Mars is so low mass and with the real properties. If you put Saturn a little different in mass, either it will not impose to go back there, or they will both go closer to the sun and we will not be here. The properties, the existence of the inner planet, the number of them, the role they have, the properties of them, and so on, are directly connected to the structure of the protosolar cloud that make this migration happen. And that's exactly the reason why all the star systems are different, because the migration is... And what I put there on the right here, the giant impact, we know, all of us know here, that the moon resulted from a giant impact, but we have not yet taken the measure of the other effect of this impact. You modify a little bit of the mass ratio of Theia, the impactor, to the Earth, or the angle of the, I mean, anything in the process of the collision, and none of the important features of the evolution of the Earth will be identical or even similar. We are there because of this very specific. It doesn't mean that it has been asked for or someone was behind that. It just means that in the huge variety of possibilities, we are on one of them, and this is the reason why Mars, the Earth is unique. Mars also had that sort of things, but we didn't have the moon responsible for the stability of the obliquity, for example. So this is what I call the ancient paradigms, where you go from simple to complex with everything going like with an arrow here. And I put that as fundamentally anti-Darwinian here. Darwin demonstrated that the evolution does not follow an arrow. That was his debate with Lamarck, and the biologists know that. And so that's fundamentally true, but not true. And the fact that life is a generic product first, and a step in that evolution has been, I'm not saying it's still everywhere, but it has been really the pregnant dogma out of which most of the people consider here. And normally the people put the brain of the man on top of that. And that's sort of scandalous, because that was really issued in the 19th century when it was native. And as you know, all the racism put in not only the brain of a human, but some humans against others, is exactly also in that sort of deterministic approach here. So that's why I prefer to show this, although it's stupid also because it's a 2D thing, so it's much more than that. Just to, and this is, to me, the take-home message concerning life, that all the evolution in space from the Big Bang has a lot of bifurcation like that. I put a few of them, and at each of them, there is a huge variety of possibilities. And it's the context who favored one pathway towards the other one. For the moment, Darwin did that for the green over there, for life. He said, okay, the context shows that there is a lot of biodiversity. But we know now that it goes much beyond that and before that. I said that about the stellar systems, and probably when we will be able to characterize all the things before that at galaxy level and maybe sometime at Big Bang level, we'll understand that there are many other possibilities for a universe to inflate, for example, and do not make atoms at all, and do not make planets or whatever it is. We are in a given pathways, and again, the context at each stage define the reason why we take this one rather than another one. So that's, to me, one of the most important things that demonstrate that life is on one of these, but there is a huge variety of possibilities, and when you start to count them, then it's uncountable. Because again, if life is defined in particular, I said the ribosome, but it may be something else, then you will understand that the number of steps to go to that is so huge that you will never, in billions of cases, find that. So this is not what I'm going to go there, but it's just to tell you why this view changed a lot to me in the important things. For example, that we do not have an origin of life, that it's a continuum process. And when, for example, now I work on the grains out of that Hayabusa 2 collected from Ryugu, and we'll do that with the Bennu samples in a year now, we have access to the very early carbon chemistry in the protosolar cloud. And I am sure that with these grains, we will find some of the specificities that were important and critical and essential, seminal, to get to the evolution of the Earth, of life on Earth, the carbon chemistry on Earth, and so on and so on. So this is something that I think we went through all that during the talk, and I want to finish thanking a lot of Nathalie to have accepted this, to me, very exciting debate. It was an experience for me. I guess it was an experience for you too. And thanks a lot. I'm sure that we'll redo that sometime in other opportunity. And thanks a lot, the AAA and E and all the organizers to have allowed us to exchange of these ideas. Thanks a lot. I want to finish by, I have only one picture, which is the pictures of our two books. So, as you know, Nathalie wrote a book. I will not show the picture, I will just show that to you. This is the book that she wrote. Both are in French, so it's very good for those who do not know French, because that's the best way to learn French, because you know the context now, so you know what is inside. It's like it's published by the editor, which is named Le Seuil, and it's named À l'aube de nouveaux horizons. Just what would be the translation of that À l'aube de nouveaux horizons in English?
Dawn of New Horizon, actually the book will be published next year in the US. So, and Jean-Pierre, I have yours too. As I said, you know, we might not, I'm sorry, I have the my background here. Maybe I can remove my background. Let me do that.
Lift it a little bit.
Yeah, here we go.
Okay,
so,
thank you very much. Okay, thank you.
And what I'd like to say is that I might not agree with all you say. You know, I think that there is no need, for instance, to oppose plurality and diversity or terrestrial life to other life. And also a number of the arguments that have been made by Ward and Brawley in 2000 when they wrote the rare earth hypothesis, a number of them have been since debunked, like the fact that the Theia impact or the position of Jupiter or the magnetosphere, the plate tectonics. You know, I think that all of this has been debunked since, but it is important to have extreme hypotheses, because what I do for you and what you do for me is that we force each other to think harder about what our question is, and as you said, articulate better question. And again, I will just finish by saying that I would love to have you and I, you know, and others, butt heads on what is the pathway. I do not believe in an origin of life. I believe that this is an emergent process, part of the universe, and started a long, long time ago. And then we can start thinking about those things and try to put to put ourselves into the life principle. And another thing that I'd like to say is that oftentimes we turn ourselves out and look outside of us to try and understand what is life. And we forget that we are made of the same stuff. And the stuff that's making us is basically also a way for us to find out more about the process of life. So remember, this is a Mandelbrot universe. It's fractal by many, many ways. So maybe a lot of the answer is also in us. I'd like very much to think with you about those things and see if what we are seeing with the process of life is something that started, 13 or so, almost 14 billion years ago with this universe and maybe before. I will stop here, but thank you again for a great read. And what I would say is that what I love about you, Jean-Pierre, that never faded away with time is your passion. And I can see that with the number of exclamation marks that you have in this book. So it's a great book, it's a great read. Thank you for writing it.
Okay. Okay, so thank you once again, Nathalie. Thank you, Jean-Pierre, for the interesting discussion. Thank you to the audience for being here with us and for the questions you made. And I wish you a very pleasant night here in Torino. And we will meet once again tomorrow at 9, right?
Buonasera.